Here we have an exponential equation and we have to solve for x in this exponential equation. Okay, here the base is 3, it's a prime number. Here also the base is 3, it's a prime number. So here the base is 9, but 9 is a power of 3 because 9 can be written as 3 square. And here the base is 27. 27 is also a power of 3 because 27 can be written as 3 to the third power. Okay, let me write this 27 and 9 as a power of 3. So my first step will be 3 to the third power, that is 27 can be as 3 to the third power, and we have exponent x for 27, the same can be taken over here, negative 3 to the x power over, and 9 can be written as 3 square, and for 9 we have exponent x, the same can be taken over here. So negative 3 to the x power equals to 82. Okay, here let's consider the power of a power rule in exponent, that is we have a to the mth power whole to the nth power. So here the base is a and we have exponent m for a, and for the complete stuff we have exponent n. So whenever we have two exponents like this, what we can do is we can switch the two exponents. So then the result of this one will be a to the nth power whole to the nth power. I just switch the two exponents. So the same thing I can do over here and here. Then the resulting equation will be 3 to the x power whole to the power 3 negative 3 to the x power over, and here we can switch the two exponents over here. Then I'll be getting 3 to the x power whole square negative 3 to the x power equals to 82. Okay, so to make the solving process easier, so I'm going to assign a new variable for this 3 to the x power, because I find 3 to the x power over here, 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 here. So let me assign a new variable y for 3 to the x power. So then the equation over here will become y to the third power negative y over y square negative y equals to 82. So because we have assumed y equals to 3 to the x power, so this 3 to the x power can be replaced by y, then it will become y cube. And if I replace this one by y, it will just be y. And if I replace this 3 to the x power by y, then it will become y square negative y. Okay, here what's the greatest common divisor for these two terms? Just y. So that y can be factored out. If I factor out y, so what I have left in the first term, for that I have to divide this y cube by the one I factored out. So y cube divided by y is equal to y square. So I have y square left in the first term, negative. So if I factor y out, what I have left in the second term? So for that I have to divide this y by the one I factored, that is y. Y over y equals to 1. So y square negative 1. Okay, now the same thing. So here, what's the greatest common divisor for these two terms? Just y. If I factor y out, then what I have left over here, y square over this y is just y. And so here we have y. If y is factored out, what I have left over here, that is this y divided by the one I factored. Y over y is just 1 equals to 82. So this y will cancel out. I get y square negative 1 over y negative 1 equals to 82. Okay, here for this one, I assume there is an exponent 2. So even if I assume there is an exponent 2, its value is still 1, because 1 to the second power is still 1. So the original stuff is not changed. So why should I take exponent 2 for this one? Because I just want to get the form a square negative b square. There is an algebraic identity for a square negative b square. Actually, this is difference of two squares. So the factored form of the difference of these two, the difference of the two squares equals to a positive b times a negative b. Okay, so actually this is one of the important algebraic identities. So I can use the algebraic identity, this algebraic identity over here. So y square negative 1 square is in the form of a square negative b square. So for a square by negative b square, we can write the factor from a positive b times a negative b. Then what can we write for this y square negative 1 square? It's y positive 1 times y negative 1 over y negative 1 equals to 82. So this is a factored form of y square negative 1 square. So here this y negative 1 will cancel out. Finally, I'm getting y positive 1 is equal to 82. Okay, to solve for y, I subtract 1 from both sides. When I do so, I'll be getting y equals to 82 negative 1 will be 81. So here I'm having y is equal to 81. Actually, y is a variable taken by us. So the original stuff is 3 to the x power. So y equals to 3 to the x power. Now the y has to be replaced by the original stuff 3 to the x power. So we can plug in 3 to the x power for y equals to 81. Okay, now I have to solve for x, that is an exponent. Whenever I have to solve for a variable that is an exponent, So what I need to do is I have to get the same base on both sides of the equation. Here the base is 3. So on the right side also I must get the same base 3 over here, so that I'll be able to compare the exponents and I can solve for x. Okay, so 81 actually is a power of 3. So 81 can be written as 3 to the 4th power. So because when I take 3 to the 4th power, 3 times, like let's write 3 to the 4th power is equal to, let's check it, 3 times 3 times 3 times 3. So 3 times 3 is 9, here 3 times 3 is 9, 9 times 9 is 81. So instead of 81, we can write 3 to the 4th power. So because I need the same base on both sides. Okay, here the two terms are equal with the same base 3. So whenever two terms are equal with the same base, we can equate the exponents. When I equate the exponents, I get x equals to 4. I have solved for x. So the value of x is 4 in the given equation.